San Francisco the foggy pub with his fiancée and the fluffy dog, Pancake. He blogs at skilldrop.co.uk. Miran Lipovaca is the author of Learn Your Haskell for Great Good. He enjoys boxing and playing bass guitar and poker. He has a fascination with dancing skeletons and the number 71, and when he walks through automatic doors, he pretends that helps actually opening them with his mind. Angus Kroll is the author of If Hemingway Wrote JavaScript, and he is obsessed with JavaScript and literature in equal measure. He works on Twitter's UI framework team, where he co-authored the Flight framework. He writes the influential JavaScript blog and speaks at conferences worldwide. He tweets at Angus Tweets. So many thanks to my wonderful fiancée, Philly, for her encouragement and support during the past 18 months. I truly couldn't have done it without her. And thanks to Pancake, our dog, for graciously allowing me to use him in my code examples. Thanks to Angus, without whom I wouldn't be here in San Francisco writing this book. Angus referred me to Twitter back in 2011, and then in 2013 suggested to Bill Pollock that I might be interested in writing this book you're holding. And to top it all, he agreed to be the technical reviewer, catching a great number of JavaScript faux pas. Thanks to Bill Pollock, Seth Kramer, Riley Hoffman, Tyler Ortman, and everyone else at No Starch Press who patiently guided me through the process of writing this book. Special thanks to Bill and Seth for massaging my writing into its current form. Thanks to the young reviewers River Bradley, Damien Champ, and Alex Chu, who had some great feedback on the earlier PDFs. Finally, thanks to Miran Lipovaca. I've been a fan of Miran for years. His book, Learn Your Haskell for Great Good, is one of my favorite programming books, and his illustrations for it are amazing. Finding out he'd be illustrating my book was like a dream come true. His pictures for this book are better than I could have imagined, and I'm humbled to have had the chance to work with him. Welcome to JavaScript for Kids. In this book, you'll learn to program with JavaScript, the language of the web. But more than that, you'll become a programmer, someone who not only uses computers but also controls them. Once you learn to program, you can bend computers to your will and make them do whatever you want. JavaScript is a great programming language to learn because it's used everywhere. Web browsers like Chrome, Firefox, and Internet Explorer all use JavaScript. With the power of JavaScript, web programmers can transform web pages from simple documents into full-blown interactive applications and games. But you are not limited to building web pages. JavaScript can run on web servers to create whole websites and can even be used to control robots and other hardware. This book is for anyone who wants to learn JavaScript or to start programming for the first time. The book is designed to be kid-friendly, but it can serve as a first programming book for beginners of all ages. With this book, you will build up your knowledge of JavaScript gradually, starting with JavaScript's simple data types before moving on to complex types, control structures, and functions. After that, you'll learn how to write code that reacts when the user moves the mouse or presses a key on the keyboard. Finally, you'll learn about the canvas element, which lets you use JavaScript to draw and animate anything you can imagine. Along the way, you will create a few games to stretch your programming skills and put what you've learned to good use. First off, read it in order. That might sound like a silly thing to say, but lots of people want to jump straight into the fun stuff, like making games. But each chapter is meant to build on what was covered in earlier chapters, so if you begin at the beginning, you'll have an easier time when you get to the games. Programming languages are like spoken languages. You have to learn the grammar and the vocabulary, and this takes time. The only way to improve is by writing and reading a lot of code. As you write more and more JavaScript, you will find certain parts of the language become second nature, and eventually you'll become a fluent writer of JavaScript. As you read, I encourage you to type out and test the code examples throughout the book. If you don't fully understand what's going on, try making small changes to see what effect they have. If the changes don't have the effect you expected, see if you can find out why. Above all, work through the try it out and programming challenges sections. Typing out the code that appears in the book is a good first step, but you'll understand programming at a deeper level when you start writing your own code. If you find the challenge interesting, then keep at it. Come up with your own challenges to build even more onto the programs you've written. You will find sample solutions to the programming challenges as well as the code files for the games and other examples at http://nostarch.com/javascript4kids/. Try looking at the solutions after you've solved a challenge so you can compare your approach to mine. Or if you're stuck, you can check the solution for hints. But remember that these are just sample solutions. There are many, many different ways to accomplish the same goal in JavaScript, so don't worry if you end up with a completely different solution from mine. If you come across a word and you don't know what it means, check the glossary at the back of the book. The glossary contains definitions for many of the programming terms you'll encounter in this book. Chapter 1 gives you a quick introduction to JavaScript and gets you started writing JavaScript in Google Chrome. Chapter 2 introduces variables and the basic data types used by JavaScript: numbers, strings, and booleans. Chapter 3 is all about arrays, which are used to hold lists of other pieces of data. Chapter 4 is about objects which contain pairs of keys and values. Chapter 5 is an introduction to HTML, the language used to create web pages. Chapter 6 shows you how to gain more control over your code using if statements, for loops, and other control structures. Chapter 7 puts together everything you've learned so far to create a simple hangman word guessing game. Chapter 8 shows you how to write your own functions so you can group together and reuse blocks of code. Chapter 9 introduces jQuery, a tool that makes it easy to control web pages using JavaScript. Chapter 10 shows you how to use timeouts, intervals, and event handlers to make your code more interactive. Chapter 11 uses functions, jQuery, and event handlers to create a game called Chapter 11. Chapter 12 teaches a style of programming called object-oriented programming. Chapter 13 introduces a canvas element which allows you to draw graphics on a web page with JavaScript. Chapter 14 builds on the animation techniques you learned in Chapter 10 so you can create animations with Canvas. And Chapter 15 shows you how to control those Canvas animations with the keyboard. In Chapter 16 and Chapter 17, you will program a complete snake game using everything you learned in the previous 15 chapters. The afterword gives you some ideas for how to learn even more about programming. The glossary contains definitions for many of the new words you'll encounter. One last thing to remember. Have fun. Programming can be a playful and creative activity, just like drawing or playing a game. In fact, you'll be drawing and playing games with JavaScript a lot in this book. Once you get the hang of how to write code, the only limit is your imagination. Welcome to the amazing world of computer programming. I hope you have a blast. Computers are incredibly powerful machines, capable of performing amazing feats like playing competitive chess, serving thousands of web pages, or making millions of complex calculations in less than a few seconds. But deep down, computers are actually pretty dumb. Computers can only do exactly what we humans tell them to do. We tell computers how to behave using computer programs, which are just sets of instructions for the computers to follow. Without programs, computers can't do anything at all. Even worse, computers can't understand English or any other spoken language. Computer programs are written in a programming language like JavaScript. You might not have heard of JavaScript before, but you've certainly used it. The JavaScript programming language is used to write programs that run in web pages. JavaScript can control how a web page looks and make the page respond when a viewer clicks a button or moves the mouse. Sites like Gmail, Facebook, and Twitter use JavaScript to make it easier to send email, post comments, or browse websites. For example, when you're on Twitter reading tweets from Nostalgia and you see more tweets at the bottom of the page as you scroll down, that's JavaScript in action. You only have to visit a couple of websites to see why JavaScript is so exciting. JavaScript lets you play music and create amazing visual effects. For example, you can fly through an interactive music video created by Hello Enjoy for Ellie Goulding's song Lights. http://lights.helloenjoy.com as shown in Figure 1:1. JavaScript lets you build tools for others to make their own art. Patatap http://www.patatap.com is a kind of virtual drum machine that creates all kinds of cool noises and cool animations to go along with them as shown in Figure 1 to 2. Figure 1 to 1. You control the flashing cursor in Hello Enjoys Likes music video. Figure 1 to 2. When you visit Patatap, try pressing a bunch of keys to make different noises. JavaScript lets you play fun games. See you. Beslam https://www.cubeslam.com is a 3D recreation of the classic game Pong, which looks a little like air hockey. Yo. You can play against one of your friends or a computer-generated bear, as shown in Figure 1 to 3. Figure 1 to 3. The CubeSlam game is programmed entirely in JavaScript. JavaScript isn't the only programming language out there. In fact, there are literally hundreds of programming languages. But there are many reasons to learn JavaScript. For one, it's a lot easier and more fun to learn than many other programming languages. But perhaps best of all, in order to write and run JavaScript programs, all you need is a web browser like Internet Explorer, Mozilla, Firefox, or Google Chrome. Every web browser comes with a JavaScript interpreter that understands how to read JavaScript programs. Once you've written a JavaScript program, you can send people a link to it and they can run it in a web browser on their computer too. See sharing your code using JSFill. Let's write a bit of simple JavaScript in Google Chrome http://www.google.com/chrome/. Install Chrome on your computer if it's not already installed, and then open it and type about blank in the address bar. Now press enter and you'll see a blank page like the one in Figure 1 to 4. We'll begin by coding in Chrome's JavaScript console, which is a secret way programmers can test out short JavaScript programs. On Microsoft Windows or Linux, hold down the Control and Shift keys and press J. On Mac OS, hold down the Command and Option keys and press J. If you've done everything correctly, you should see a blank web page and, beneath that, a blinking cursor next to a right-angle bracket greater than as shown in Figure 1 to 4. T. That's where you will write JavaScript. Note the Chrome console will color your code text. For example, the text you input will be blue and output will be colored based on its type. In this book, we'll use similar colors for our code text wherever we're using the console. Figure 1 to 4. Go. Ogle Chrome's JavaScript console. When you enter code at the cursor and press enter, JavaScript should run or execute your code and display the result, if any, on the next line. So, our example, type this into the console. Let's create something a bit sillier JavaScript program to print a series of cat faces that look like this. Equals. Unlike our addition program, this JavaScript program will take up multiple lines. To type the program into the console, you'll have to add new lines by pressing Shift-Enter at the end of each line. If you just press Enter, Chrome will try to execute what you've written, and the program won't work as expected. I warned you the computers were dumb. Type this into your browser console. Draw as many cats as you want. var draw cats equals function how many times. For var I equals 0, I less than how many times I. Console logi equals. Semicolon. Draw cats 10. You can put any number here instead of 10. At the very end, press enter instead of shift enter. When you do that, you should see the following output. 0 equals. 1 equals. 2 equals. 3 equals. 4 equals. 5 equals. 6 equals. 7 equals. 8 equals. 9 equals. If you made any typos, your output might look very different. You might get an error. That's what I mean when I say computers are dumb. Even a simple piece of code must be perfect for a computer to understand what you want it to do. I won't go through exactly how this code works for now. We'll return to this program in Chapter 8, but let's look at some of the features of this program and of JavaScript programs in general. Semicolon. signs, and a few words that might seem mysterious at first, like var and console.log. Dot. These are all part of JavaScript's syntax, that is, JavaScript's rules for how to combine symbols and words to create working programs. When you're learning a new programming language, one of the trickiest parts is getting used to the rules for how to write different kinds of instructions to the computer. When you are first starting out, it's easy to forget when to include parentheses or to mix up the order in which you need to include certain values. But as you practice, you'll start to get the hang of it. In this book, we'll go slow and steady, introducing new syntax little by little so that you can build increasingly powerful programs. Draw as many cats as you want. This is called a comment. Programmers use comments to make it easier for other programmers to read and understand the code. The computer ignores comments completely. Comments in JavaScript start with 2 forward slashes. Everything following the slashes on the same line is ignored by the JavaScript interpreter. So the comments don't have any effect on how a program is executed, they're just there to provide a description. In the code in this book, you'll see comments that describe what's happening in the code. As you write your own code, add your own comments. Then when you look at your code later, your comments will remind you how the code works and what's happening in each step. There's another code comment on the last line of our program. Remember, everything after that isnt run by the computer. Draw cats 10. You can put any number here instead of 10. Code comments can be on their own line or they can come after your code. If you put it at the front like this, draw cats 10. Nothing will happen. Chrome sees the whole line as a comment, even if it's JavaScript. Once you start reading JavaScript code out in the wild world, you'll also see comments that look like this. Slash. Draw as many cats as you want. Slash. This is a different style of commenting which is typically used for comments that are longer than one line. But it does the same thing. Everything between and is a comment that the computer won't run. In this chapter, you learn a bit about what JavaScript is and what it can be used for. You also learn how to run JavaScript using the Google Chrome browser and tried out a sample program. All of the code examples in this book, unless I say otherwise, can and should be used in Chrome's JavaScript console. Don't just read the code, try typing things out. It's the only way to learn to program. In the next chapter, you'll start learning the fundamentals of JavaScript, beginning with the 3 basic types of information you can work with: numbers, strings, and booleans. Programming is all about manipulating data, but what is data? Data is information that we store in our computer programs. For example, your name is a piece of data, and so is your age. The color of your hair, how many siblings you have, where you live, whether you're male or female, these things are all data. In JavaScript, there are 3 basic types of data: numbers, strings, and booleans. Numbers are used for representing, well, numbers. For example, your age can be represented as a number, and so can your height. Numbers in JavaScript look like this. 5. Strings are used to represent text. Your name can be represented as a string in JavaScript, as can your email address. Strings look like this. Hi, I'm a string. Booleans are values that can be true or false. For example, a Boolean value about you would be whether you wear glasses. Another could be whether you like broccoli. A Boolean looks like this. True. There are different ways to work with each data type. For example, you can multiply 2 numbers, but you can multiply 2 strings. With a string, you can ask for the first 5 characters. With Booleans, you can check to see whether 2 values are both true. The following code example illustrates each of these possible operations. 99,123. 12,177. This is a long string, slice 0, 4. This. True, false. False. All data in JavaScript is just a combination of these types of data. In this chapter, we'll look at each type in turn and learn different ways to work with each type. Note, you may have noticed that all of these commands end with a semicolon. Semicolons mark the end of a particular JavaScript command or instruction, also called a statement, sort of like the period at the end of a sentence. JavaScript lets you perform basic mathematical operations like addition, subtraction, multiplication, and division. To make these calculations, we use the symbols and which are called operators. You can use the JavaScript console just like a calculator. We've already seen one example, adding together 3 and 4. Let's try something harder. What's 12,345 plus 56,789? 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. 69,134. That's not so easy to work out in your head, but JavaScript calculated it in no time. You can add multiple numbers with multiple plus signs. 2, 2, 3, 3, 4, 4. 99. JavaScript can also do subtraction. ... 1,000 to 17. 983 and multiplication using an asterisk. 123,456. 56,088 and division using a /. 12,345 250ths. 49.38. You can also combine these simple operations to make something more complex, like this. 1, 2, 3, 4, 5, 7, 3 31 quarters. 1,397.25. Here it gets a bit tricky because the result of this calculation, the answer, will depend on the order the JavaScript does each operation. In math, the rule is that multiplication and division always take place before addition and subtraction, and JavaScript follows this rule as well. Figure 2 to 1, T. Key order of operations: multiplication, division, addition, subtraction. Figure 2 to 1 shows the order JavaScript would follow. 5. RSD JavaScript multiplies 57.3 and gets 171. Shown in red. Then it divides 31 quarters to get 7.75. Shown in blue. NE. XD it adds 1, 2, 3, 4, 171 to get 8/13. 11. That can't be right. You can't give each sibling 11 candies when you've only got 8. The problem is that JavaScript does division before addition, so it divides 8 by 1, which equals 8, and then adds 3 to that, giving you 11. To fix this and make JavaScript do the addition first, we can use parentheses. 8/13. 2. That's more like it. 2 candies to each of your siblings. The parentheses force JavaScript to add 1 and 3 before dividing 8 by 4. Try it out. Let's say your friend is trying to use JavaScript to work out how many balloons to buy. SHE's throwing a party and wants everyone to have 2 balloons to blow up. There were originally 15 people coming, but then she invited 9 more. She tries the following code. 1592. 33, but that doesn't seem right. The problem is that the multiplication is happening before the addition. How would you add parentheses to make sure that JavaScript does the addition first? How many balloons does your friend really need?